Welcome everyone to today's presentation. My name's Scott Boutler. I'm the Academy instructor here in Langley, British Columbia at the Viessmann's Western Canadian office, and I'll be the voice behind the screen today. Joining me today to answer some of your questions and keep me on point from Viessmann's North American headquarters in Waterloo, Ontario, is Academy instructor Mark Norris. Mark has a couple things to say. Hi, Mark.
How you doing, Scott? Welcome, everybody. Yeah, just a couple of housekeeping things. There is a questions box somewhere on your screen. If you have a question as we go along, type it in. I will answer the questions hopefully in real time, and things that we don't get to in time or things that I think we need more speaking answers, we'll do at the end. If there's a question that you want just answered to you, then make sure that you put in your question that you want a personal answer, and I will just answer to you alone. Other than that, all the questions get answered to everybody, so everybody sees the question. If you had a question, I'm sure somebody else had that same question, so that's generally the way we do it. So I'm going to turn it back to Scott in a second here. While we're talking about the things that are going to get, the PDF of this presentation and a list of these questions and answers will be emailed to everybody who logged in today. So you'll have a record of that later on. The video will be archived on the Viessmann North America YouTube channel, so you'll be able to watch it later as well if you want to go back and recap something. Okay, I'll turn it back to Scott.
And thanks, Mark. So as Mark had mentioned, he's going to be looking after those questions and like I say, get those in. If you can't stay with us for the full hour, this is going to take about an hour. I'm going to try to stay on point here this week and get to this information in a timely fashion. If you have to leave for whatever reason, you still have those questions. You can get those into us. We'll make sure to get those answers back to you. So we'll endeavor to get that information into your hands, as we know it's important for you to have that information that you're requesting. But as part of this presentation today, what we're going to be reviewing basically is the boiler control as a troubleshooting tool. So we have this boiler control on some of our boilers. Important that we understand that it has information for us to basically gather. So like your multimeter, your manometer, screwdrivers and wrenches that we have and we carry around to site, in our toolbox. The boiler control is going to contain a lot of information to help us, just like those tools do, in diagnosing and correcting the issues that we are confronted with when we're standing in front of a boiler. As long as we know where to look, and that's kind of the key. Lots of information, but oftentimes we don't know where to look or where we're going there, then it's going to be that much more difficult. So the idea is to get this information to make those troubleshooting and diagnostics that much quicker and more efficient for you. And what we're going to cover today is basically just one address. So there's lots of different areas of the boiler control we can look at as far as diagnostic tools. We're going to look at one single address that's available in our boilers that will, I think, in my opinion, once you understand where to get the address, where to find it, and how to use it, it's going to become a pretty valuable addition to your toolbox moving forward. And Mark and I, like I say, we kind of endeavor the objective of all these presentations that we're putting together on troubleshooting, et cetera, as just to continually provide you guys and give you guys information. We're sharing what we've come across by doing presentations and doing in-house work and doing site visits and that sort of stuff. But I want to share these little bits of these little valuable nuggets of information to you guys. And that's going to increase your knowledge, your skill set with Viessmann products, your confidence when you're working on these products. And that's kind of basically the whole objective of these presentations that we're doing, is just to get that and basically increase your skill set and your capabilities when we're confronted with different issues in front of the boiler. So saying that, we're going to get started on this little presentation on the fault code address number 38. So So we'll get started here. First, just a quick review of the boilers. So not every Viessmann product you'll have that address 38 and it actually contain this piece of information, but it does apply to the boilers you see in front of you here right now. So if you look at the picture there, there's actually two generations of boilers, or three generations of boilers actually there. There's a B2 series of boilers, they're the ones with the black screens or black controls on the face there. There's a B2TA, B2TB, that's the guy in the middle. So it has two generations. There's an A series and a B series there, just a generational change in the boiler. B2HA and B2HB, so again, a couple of generations of the B2 series of boiler here, but all of the different sizes of that boiler will have this address 38 in it as well. We're going to go back in time here a little bit, jump in a little time machine, go back to the WB2B series of Vitodens 200, where this address 38 will be revealed as well. I want to mention, though, that not all of the address 38 values are going to be part of the WB2B. There will be a couple that will reference. I'll mention those as we move through here, which ones apply to the WB2B and which ones are very specific to the boilers, that you'd see that address on. So some of these things as we move through, not all of the values are going to pertain to all the boilers. Some are specific to certain sized boilers in a product line. With that information, we're going to find out where we can find this fault, this address 38. So that's a pretty important piece of the puzzle here is, where's it located? How can we get access to it? Once we get access to it, then we can start to do something with this particular address. So the first thing we need to do is get into service of the boiler. And I've cut and pasted a couple of pieces from our product documentation, the manuals that provide all this information there. Again, if you know where to look, it's in the manuals. First step is to get into service. We have to hold down the OK, and you see my my fingers there on the OK button, and the very bottom button, the menu key. So the OK and the menu, hold those down for about 4 seconds, and then that screen is going to change, and you're going to see it move into this particular screen you see in front of you, the service screen. And I should mention, backing up there, this is the screen. Just going to put my little highlighter on here for a second, laser pointer. This screen here is part of a multi-boiler system. So if you're a residential service contractor, only work on residential products, this screen may not look right to you. You might be, well, that doesn't look like the boilers I'm working on. It's actually the same control. It's just been programmed for a multi-boiler system. So when we hook up a Vitodens unit to a cascaded control, we're controlling more than 2 or more boilers. We have to change the control into this style of screen. So the typical screen you see in standalone would have the outdoor temperature, little picture of a house, or kind of an enclosure of a house or outline of a house, and the indoor temperature inside. This is the standard multi-boiler screen where you see the boiler number, the temperature of the boiler, and if the pump is running, and if it was firing, you'd see that as well. So just a kind of a review there. It is the same control, just programmed for a multi-boiler application. So we've hit that OK and menu key. You've got to the service screen here. What's the next step? We need to move our finger from the bottom up to the top. So we maintain and hold the OK button, but we're going to press the very top button, that back key. So the reverse arrow, you see that on the left-hand side, and we're going to hold that down. So there, I've changed my position of my fingers there now, and this is going to get us into coding level 2. So we go from service to coding level 2. And then from there, we are going to scroll to boiler. In the multi-boiler application, you see the choices there, and the menus are limited, basically general and boiler. If you're in a standalone application, you would see a lot more information. If you had domestic hot water, you see a DHW there on the menu, and if heating circuits, etc. We're going to hone in on just that one area of the menu that you're going to see in both multi and standalone applications, just the boiler. So I have highlighted that in red to the left there. You're going to scroll down using the down arrow key, highlight boiler, press OK. And then you're going to use the navigation arrow keys there, the right or left arrow keys up or down, and you're going to scroll to address 38. And you'll see that there on the screen. So the highlighted address 38. And the value there is what we're really looking at. So in the manual, if you were to look at that address 38 and you saw it was 0, it would just tell you basically the boiler was operational. There's no faults. If that value is anything other than 0, then the boiler would be in some sort of a fault mode, some sort of a status there indicating that the unit's blocked because of a specific bit of information or some sort of a problem that the unit needs to overcome. So that is the where the address is and the information there. And basically it's a readable address. We can't actually change anything by looking at the address. It's just going to give us a value there that we can use to help us troubleshoot. And essentially what you see at address 38 is something we call a detailed fault code. Detailed fault code, essentially if you see the little red light is illuminated on your boiler control, you see that little red light there on the left-hand side of the control is flashing or solid, and you see the fault triangle with a lightning bolt flashing on your screen. That boiler is basically locked out because it's in some sort of a fault. Once we push the OK button, you would actually see the fault on the screen there. It would tell you what it was. And if we were to look in the manual, it would show us the fault code. So the fault that you would be seeing on the screen would be one of these ones here on the left. The detailed fault code is inside this little highlighted area right here. So that information we can actually use to help us troubleshoot. And that information, not all of the faults are going to have this detailed fault code, but when they do, it can give you some really a good piece of information to help you solve your particular issue that you're working with. So where am I going to find out what these detailed fault codes actually mean and how I can utilize them? On our website, so this is the Viessmann US website. I've got a link right there. If you were to copy and paste that link on your web browser, it would take you right into this area. And we're looking at the Pro Resources area of the Viessmann US website. And the information that we're going to talk about is located in this particular area. If you load the Viessmann Orange app onto your device, whether it's your phone or your tablet, your laptop, whatever it is, then you would have instant access to a lot of this information as well. You're right there on your phone. Product documentation would be there. Very simple, basically like a click of a button and you're in the Viessmann world. In Canada, we have our Viessmann.ca website, and instead of the Pro Resource, we have the Pro Toolbox area. Same thing. We just have that information located in basically just name it a little bit differently. Same idea. If you put the Viessmann Orange app on your phone or on your your whatever device you use, then you're going to have that much more quicker access to this information right there at your fingertips, as long as you have a Wi-Fi connection or internet connection to work with. And what we're going to hone in on here when we get into other Pro Resource or Pro Toolbox is the technical service bulletin area. And what this area is would be bits of information that might not yet have made it into the manual, or they're in sort of the next update that might be included in the next product manual for information. But this is some pertinent information that we want you, the service contractors, to know is available. So a bunch of different topics here that you can look at. We're going to kind of hone in on the TSB Technical Service Bulletin 009. Which is detail fault codes at coding address 38. So when we look at this, you can load it in you can download this, you can print it off in a PDF, you can put it into a spreadsheet in Excel formats. It's a couple of pages of different faults and of course the detailed fault code that's associated with it. So if I were to kind of put the actual manual information here on the screen, our troubleshooting area of the manual, and you've got the technical service bulletin here, the detailed fault codes. How we would use this is specifically I find in this particular application of address 38, it's usually when you see two detailed fault codes that you have information there that's going to be quite useful. Usually with the single detail fault code, all the information is already provided in the manual for you. But if you see this one here, for instance, the fault EC, you might see flashing on the screen. If I go to address 38 and I look at that address 38 and it says 67 as the value, that's just going to be press the reset button and continue on. There was some sort of an issue as far as our parameters during the calibration of the burner. So when the burner went to fire, some sort of a step there or parameter wasn't read, and of course it locked the burner out. If I was to look at address 38, instead of 67, I saw 195, that would tell me that I would need to replace the boiler coding card and then press the reset button and continue on. So there's an extra step there. The coding card is corrupted and we would need to replace that, and that would solve the fault EC. So you can see there's some valuable bits of information there that give you a little bit more detail as to what the corrective action is, so you can get that problem solved and move on from it. So there's some of those areas in this where you see detailed fault codes that you'd want to have a look at. More specifically, what we're going to be dealing with here today as far as a topic is when that fault light is not illuminated. And there are some values of address 38 which you will not see the fault actually cause that red LED, that lamp, to light up, or you'll see a fault flashing on the screen. And those are highlighted here in red. So I basically took those down. There's a number of these. About half of them are actually factory faults. So they use them at the factory when they're doing tests on the boilers and on operation. So those ones there we're not gonna talk too much about. I'm going to detail the ones we are going to cover here in a moment. But it's good to know that there are some faults on the control you might not see that red light actually light up on. But if you understand and know where to look for information, you might get a really good piece of information or a bit of nugget that will lead you to figuring out what that problem is or why that boiler is not firing. And we see those values right here. So if I went to address 38 and I saw a value of 2, that would be a specific piece of information that control is trying to tell me why that burner is not firing. If I saw a 3 there, that would be another reason. We're going to cover 2 and we're going to cover the value of 3. 5, 6, and 8 are really factory used values, so we're not going to cover those 5, 6, and 8. But we will skip down to 29, so we'll talk about 29 and about 33. So using the 29 there, we're going to do a lot of basically control and wiring schematic type of tracing and navigation there. So you're going to get a pretty good idea once you push that power button where that power moves through the control. And if there's an issue with that, that's where you're going to see some of these faults light up here. So as we move forward here, we're going to get pretty detailed in the control wiring you know, the relationship between the pump module at the bottom of the boiler where you wire the power to, and of course that control console at the top, and how they're integrated and connected together. We're going to see that. So first off, we want to look at, as I mentioned, those addresses, or address 38, the value that does not cause that red LED to flash. If I had a burner that wasn't firing, I got the call, the no heat or no hot water situation, and I stand in front of the boiler, no fault code, you know, what do I do? There's no information there. Well, now I know I can go and check out address 38. So that's a really big, you know, important step as far as the troubleshooting process. And address 38, I scroll there and I see that value is not 0 now, it's 2. And the information when that value is 2 is the gas supply. There's no or low gas pressure detected. So we need to check, you know, where the gas supply is, if that pressure is good or not. So very direct bit of information there. It's a gas delivery problem that is causing this burner basically to not fire. So we are immediately honed in on that side of the boiler. And I have to mention this is one of those values that you are not going to see on every one of the models of boilers that we're talking about. This is very specific to the B2HA 112 or 150. So that was the previous nomenclature for this particular boiler. That would 112, 150 be like the kilowatt input, basically. Now we've moved to BTU inputs on our nomenclature. So now that B2HA112 is now a B2HA399. The B2HA150 is now the B2HA530. So you're not getting, 5 times the boiler power there, or 4.5 times. You're basically, one is kilowatts and one is BTUs. So this particular fault address or value of 2 is specific to those boilers. So the largest of the B2 series of boilers that Viessmann makes. And if we kind of dig a little bit deeper, drill down into what the issue is, it's sitting up here on the wiring schematic. So this is where our problem, or why that particular unit is not firing. It's a relationship with this particular component that is connected to the boiler here. So this input is not reacting correctly, and of course the boiler is not firing as a result of that. And that is a gas pressure switch on the particular B2HA 399 or 530. So these boilers are unique in the fact that they actually have a built-in gas pressure switch. The other units that are we're going to talk about today do not have internal gas pressure switches. If there was a gas pressure switch, it would be something that was installed in the field. So it would be basically outside of the boiler, but wired and connected to the boiler and interlocked in that particular respect. This is internally wired to the control console from the factory. And what that is basically telling you, so we're looking here now at a picture of the B2HA 399 and 530. And we're down here at the gas valve. And if I was to take that gas valve and take one out of the boiler here and show you what I'm talking about, first problem is there is the gas connection. So this is where we would actually test or measure our gas pressure. So if you saw a value of 2 there on address 38, the first thing that would be to basically check that gas pressure. What is that gas pressure? And what is it? Is that basically the reason why the burner is out? So we're looking for a minimum gas pressure here in order to make sure that that burner can fire. The switch itself is connected to the boiler control right here. So I'm holding that little white switch, or that little plug. This is the connection from the gas pressure switch to your boiler control. Now we're going to actually use this as a troubleshooting tool as well. We'll have a look at that there in a second. So I can put my magnehelic gauge, my manometer right here, and that's where I would measure my gas pressure. All right, so we're looking for, just a quick review of all the boilers. Essentially anything below 4 inches, we need to increase the gas pressure. So it doesn't matter what size boiler you're talking about, whether it has a built-in switch or not, it's 4 inches is the minimum gas pressure that we want to see. 14 is the maximum. So we're outside of the range, and that's why the control is locking that particular burner out. We need to get that gas pressure up. If I flip that gas valve around, there you'll see that little wiring harness, and we see GDW1. So that is Gas Druckerwasser 1. That's my German. Sorry for anybody that actually can speak it fluently. But that is your gas pressure switch 1, and that's your low gas pressure switch. It's factory set, you can see there at 4 inches, and the connection there is a open on a correct gas pressure. So if the gas pressure is above 4 inches, the GDW1 opens the connection contact. It doesn't close it. It is a normally closed connection. So if that switch doesn't open, it stays in the closed position, that's going to cause that 38 to be a value of 2. All right. Another way of testing this, and if you kind of relate it to, I know a lot of guys have gone through some of the troubleshooting of flow switches, for instance, in Vito-Dense boilers. So all the ways back to the WB2A, generation we introduced, in the early 2000s to North America here, and there was always a flow switch, and there still are flow switches internal to our boiler. So they're actually the first line of safety. And if your flow switch stopped, working, it didn't close, for some reason the burner had a call for heat, it wouldn't fire, but you wouldn't get a fault on the particular boiler. And the test for that a lot of times would be if you call tech support, they would say just jumper the flow switch. So basically unplug the connection, put a jumper across the harness that goes back down to the control, and when you put a jumper across that, you short it, you effectively fool the control into thinking that flow switch closed. And if that was blocking the burner, you would quickly discover that the burner would start to fire or the fan would come on, and you would basically, okay, the flow switch was the issue here. Very similar with these particular boilers. If you can remember, it's very specific to the B2HA 399 and 530, as I mentioned. If I am in front of one of those particular boilers and I see this little white switch here, there's no fault on the unit, but there is a call there that burner should be firing. If I just unplug that connection, that would be enough to basically open that switch, as I talked about earlier. When the switch opens, the burner will go into its operation or trial for ignition. So if I open the switch and it was the reason why the burner wasn't firing was because 38 was 2, this would actually go back to the control and essentially prove that there was gas pressure, and now the burner would go into its operation. So one of two things are going to happen. Your burner's going to fire and everything's going to be great, or you're going to lock out probably on an EE fault. So one instance there, we might have a faulty gas pressure switch. So if the pressure was indeed above 4 inches, but that burner wasn't firing, it could be the switch at the back is faulty and needed to be replaced. If I unplug that and the burner goes into EE fault, then of course the burner control was telling us the truth there, that the gas pressure was too low. So again, 38 being a value of 2 is a low gas pressure. As a result of these particular controls having an internal low gas pressure switch, and there's a couple things here we can utilize. So you can go to address 38 and see a value of 2. You can stand in front of one of these boilers and just quickly unplug that connection, see if the burner fires. Both will lead you down the same kind of avenue as far as your diagnostics. Either we have a low gas pressure situation, or we need to replace a low gas pressure switch. The next one that was in line, again, this is going to be specific to a line of boilers and not others, is when instead of 2, we see a 38 of 3. And basically, the boilers we just talked about, the B2HA, 112, 150, 399, or 530, depending on the year you purchased the boiler, how old it is, it might be named differently. Those units do not have flow switches. Therefore, they are not part of the value of 38 being 3. So you won't see a value of 3 on those particular boilers. You're going to see it on these ones right here. So the B2HA and B2TB models of units, we see the wiring schematics. The B2HB 19 up to 35 are basically in BTU 68 to 125. We'll see the little picture there of the connection that is causing the blockage of the burner, and this value 3 to be on address 38. The larger boilers as well, so we get into the B2HB 4557, which are now 161.99, or all the ways up to the 285 to 352s. You'll see the schematic there where we got and highlighted. And this relates to also the previous generation of 200 boilers, the WB2B. We'll see that the connection right there that's causing this blockage to our burner. So as I mentioned, these are all flow switch connections. Some of them you'll notice here are single connections. So the 125 B2TB is one flow switch. Same with the 68 to 125s. You get into larger boilers, the WB2B, previous generation 80 to 105, there's 2 flow switches in series. You can see how they're in series there. As well as the B2HA 285, 311, and 352s, they'll have 2 flow switches as well. The 160 and 199 will just have a single flow switch. They're not 2 flow switches as depicted here. So the flow switch in this case is not closing when there is a call for heat. And that could mean one of 2 things. It could be a flow switch is basically faulty. We need to replace the flow switch. Or we're not meeting a minimum flow rate of that volume of fluid going through the heat exchanger meeting these particular minimums. So every flow switch, basically it's a mechanical device. It only has one value that it reacts to, and that's that minimum value. So once we meet the minimum criteria, it's going to push that flow switch to the closed position. That's going to feed back to the control saying, we've got flow, we've verified it, we can fire these low mass boilers. So part of a low mass unit is typically to make sure there's a minimum flow rate. Because we fire that burn without flow, within seconds you're tripping on an F2 fault. So this is the first criteria is to make sure we have flow. Then we fire the burner and we start to modulate to set point. So you can see on the B2HA 285 up to 352, there's actually 2 flow switches. So cumulatively, if we have 2 flow switches, we've got to add those flow rates together. So 2.65 per flow switch, we need at least 5.3 gallons a minute through those bigger boilers to get that unit to operate. And that would be similar to the WB2B 80 and 105s as well. Same kind of BTU inputs, just a generation older. Similar flow switches are in mind there. And just to kind of look at a flow switch, they are a magnet. Basically, that little paddle, it's directionally sensitive, which means the flow has to be into the boiler on one particular side always and coming out on the other. So we always flow into the right-hand side of a Vito-Den's boiler, pushing into the boiler, and then coming out on the left-hand side is typical. And the flow switch is positioned to basically pick up flow in that direction only. So if we go the reverse, that flow switch is not going to work for you. We have to go in the right direction. As I mentioned, it's a magnet. It's not a spring. It's not a spring-loaded flow switch, which means it tends not to wear out like a spring would over time. So opening and closing, that spring would start to lose some of its capacity. With a magnet, we tend to stay in a pretty good, as far as that magnetism to pull that flow switch back to the open position after the flow was stopped. Another good reason why flow switches, because they're part of the system, they're internally connected to the quality of the water or fluid that you're flowing through that boiler. If you've got a lot of dissolved solids in your system there, you've got a lot of acidity in your water, you got some poor water quality, you got a lot of deposits kind of floating around in there. Remember, this is a magnet. And where are those deposits going to end up? Most likely plugging up your flow switch. So if you see a lot of flow switches sitting in the corner of that mechanical room, it's not the manufacturer of the flow switch is the problem there. That is an issue with your water quality. And until you address that, you're going to continue having issues with your flow switch. You're going to continue having address 38 show up at a value of 3. All right, so the easy way here to check this, kind of similar to what I kind of mentioned earlier. A lot of times you call tech support, you're standing in front of one of these boilers, they're probably not even going to get you to go to address 38. They're just going to say, well, let's jump the flow switch. So we find where the flow switch is connected to first. And you can see here, it's usually identified with a 33 as far as the plug connection. We find that plug connection, unplug the flow switch from the wiring harness, and you see here, I put a jumper shorted across that connection, and that's going to fool the control into thinking that there's flow through the boiler. And when I do this, there's going to be one of 2 things that are going to happen. They're going to either fire that unit up. If the flow switch was basically faulty, the boiler's going to light. We've got the correct amount of flow rate. We're just not picking it up through the flow switch. And the burner's going to modulate. It's going to deliver the heat, and everything's going to be great. And essentially, your directive at that point is to pick up a flow switch to replace it there. If you jump that flow switch and the burner fires, and then you're sitting there and you hear some percolation, and then the fault flashes up on the screen there, and you hit the OK button and you see F2, that would indicate that the boiler had no flow, and we tripped the fixed high limit as the boiler was in firing. And of course, we weren't getting heat away from the boiler quick enough. Some of these boilers only have a gallon of water in there. So if we're throwing in, 30, 40,000 BTUs on ignition, it doesn't take too long for that to trip the fixed high limit. And at that point in time, now we need to do a little bit more troubleshooting. Why did clearly the flow switch is not the issue here. At least we can't say that just replacing a flow switch is going to fix our problem. But what we're going to have to do is have a look at what is creating the flow. So we see the pump here in the background. and I'm doing an amp draw on that pump to get an idea of where that pump is. So is the pump actually running? That's the first thing. If you come to one of the Viessmann academies, one of these days we'll be welcoming participants back into our offices here to take in some training. Like I said, we give you the little pump indicators, little flow indicators, little spinners, and they're actually pretty useful for this type of diagnostics, just to check to see which pumps are running. But if we trip on an F2 fault after that occurs, we need to get that amp meter out. We need to check to see what that amp draw is in that pump. Or, sometimes the pumps are really, really hot when you touch them. That's a really good indication that we're starting to overdraw amps and that flow rate isn't where we want it to be. So we need to do a little bit more troubleshooting once we trip that fixed high limit, just to see what's going on as far as the flow rate through the boiler. So is something isolated? Is there an isolation valve that's been closed? Something is causing that unit basically to not have the proper flow rate. So these are some of the things we want to look at when we see that address 38 is a value of 3. And like I say, once you understand this and know it, you're right on the cusp of figuring out that particular situation. But without knowing what's going on, without a fault flashing at you, it's very difficult. So hopefully you guys are picking up that address 38 can be pretty valuable to you to look at some of this information. And so that's the address 38. As again, we've those two, the value of 2 and the value of 3. So low gas pressure in the bigger boilers, no flow in the smaller boilers would be the indication of that. Now we move into the value of 39 and address 38. You see that here on the screen. And when I see that, it's telling me that the reason why you see 29 there in address 38 is there's an open circuit at terminals 1 and L on the multi-terminal of the power pump control module. So check the connections of terminals 1 and L. There's a jumper or installed safety equipment that might be on there. We're going to review some of that information in a bit and have a look at how that, why that power is not getting to the right area of the control. And that's going to get into a little bit of wiring here. So there's the schematics, and what we're looking at here, regardless of the boiler that we're talking about. Now this is specific to the B series of boilers. So again, the only address that we're going to cover so far that is relative to the WB2B was the value of 3. This 29 is specific to the B series, the block control interface controls, because they are wired a bit differently from the WB2Bs. So the schematics are here. So it's a relationship between the control console and the pump module below. And again, regardless of the boiler that we're dealing with here in this generation, the wiring that we're related with here is all the same. So the same troubleshooting diagnostics for the small boiler that we would apply to the big boiler if we see that value of 29 on address 38. So we're going to have to trace the wires here. We're going to have to trace where that power goes to get a good idea of where we need to troubleshoot. And the first kind of area to look at here is, of course, the different boards that we're dealing with. So we have them here in front of you. This is kind of what you see when you're staring at them. We want to kind of lift the shroud here a bit and look inside of these controls to see how that control is wired up. So if I take the cover off the pump module, you'll see that there's a bunch of relays in there we're going to talk about here in a moment, and some wiring connections there. We've got some fuses. Where does all that stuff go, and what are we connecting to there when we hit the power button? And the control console itself. So this is you can see by the module here on the left-hand side, which is an accessory. Doesn't come with every boiler. Usually if you see this as a communication module for a commercial boiler application, or it might be LAN for like remote access, Vito Connects or VitoCom systems that you're working with. But this is the control of a B series boiler tilted down. So it could be a B2TB, it could be a B2HA 530. The control here, as far as the wiring, is all similar. The different part numbers, but the connections are the same. And these relays, when we look at the wiring schematic, are kind of detailed a little bit differently. So you'll see the numbers down below here. We've got a K2, K6, K5, K3, K4, and K1. And highlight those there for red for you. You can see them a little bit better. And the schematic itself kind of separates the relay coil, and they call that A, from the actual switching contact, B. So when we look at the schematic here, you're going to see the relay coils in one area and the switching contacts in a bit of a different area, and they define them with A and B, just to make it a little bit easier for you to understand what the schematic is trying to relate or detail to you here. So you can see that here. There's K1A, so there's the coil. There's K1B, there's a switching contact down below. So don't actually connect them together. There's the K2A and the K2B. I think you're getting the picture here. K3A, K3B, and 4A, 4B, and 5 and 6, A and B. So the coils are up in here, and they're basically connected. You see the wires up above. We're going to get that in a second. And then, of course, the switching action is down below. So when we when we get an energize a coil here, that contact down here is going to close, and some event is going to occur as a result of that action occurring. And the connections are basically joined here between the control console, which is at the top of the boiler, and of course that pump module down below. And these are the connection points that you see on the schematic. And those connection points are detailed here. So 1 through 9, we only have 8 contacts, but there's 1 through 9 connection points here. Connection point 4 is actually not used. You won't see anything on 4 here in the schematic when we get to that point. But there's the connection between the pump module and the control console that sits above it, are all at these points here. Great testing points to look for different voltages and stuff like that, as there should be specific events that happen to make those relay coils energize and close the contact. So good points here to test, and those are what we're going to review here as we move through. So as we need to map that voltage as it moves through the control to understand why the 29 might be appearing on address 38. So we're going to kind of separate this a little bit and just kind of pick it apart, so there's not so much stuff kind of coming at you here at once. So the first thing we're going to just do is have a look at when we put the power to the control. For people that have been using Viessmann for years and years and years, all the ways back to previous generations of controls, we've always used typically a color of a plug, which is usually green, and a number for power into a control. So if you're looking for the 120 volt, sometimes it's 230 volt, depending on the generation control, you want to see where that power is terminating on the Viessmann device. It's going to be at the 40 plug. So 40 plug indicates power into our controls. Of course, anything with flame rectification, we talked about fault EE and EB last week. I think Jay is presenting a Vitodens 200 presentation tomorrow. He's going to be talking about service and maintenance of Vitodens 200s, as well as control navigation, and he'll probably come up with talking about that plug 40 and the importance of it being polarity correct. So you make sure your line and your neutrals are not switched when you wire up a 200 boiler, because it's going to use that for flame rectification. So power comes in on the 40 plug. It's 120 volt on these boilers, right? 120 volt on the B2 series boilers goes in. And the power, basically, we're going to define in red that you wire the control. So there's the L, or the 120 volt coming in. And the first thing that it hits there is going to be that F1 fuse, which is 6.3 amps. And then it's going to move over, and it's going to sit now and just wait for this particular contact here to close. And that's on the K1 relay. So we're waiting for the K1 relay to energize before that little gate will close. And now that power can move through and go to whatever point it needs to go to. So we hit a fuse right here, 6.3 amp fuse. And then that power just sits right here waiting for that relay to close. And in yellow, we're going to highlight the next connection where that power goes through and we wire up the control. So F2 fuse, the F2 fuse now, same actual fuse as far as its amp and load. It's a 6.3 amp fuse. And the power goes through and sits at another gate. So now we got another gate sitting here, and that's the K1 K2 connection there. So that's K1 and K2 relay contacts, switching contacts. Basically, those are open right now, and that power is just basically sitting there idle, waiting for that contact to close and to move on to its final destination. The neutral, so we're getting the pump module, we'll kind of move up here with the neutral as we move through. When we put the neutral on here, and that's all live, you see that the neutral basically goes over and parallels down to all of the connections, all your outputs. So when you wire your pumps, etc., there's the neutral that it ties to as your main power in here. It's all teed off here. And then that in purple is our neutral. It's going to go up, and this is where it's going to move up into the control console. And we're going to detail that there. So there's the neutral. So lots of wires there. It's just nice and easy to be able to detail it this way here to show you where that power is moving. And of course, the first thing it hits when it comes up through the pump module, it's going to sit on a green plug, which happens to be the 40 plug. So that is the powered connection for the control console. And kind of mentioned this when we are talking about flame rectification, checking for power and stuff. This is a really good area to check for polarity and stuff like that in your controls, is at this particular area of your device, of your control. And then the power moves through and it sits down here waiting for another contact to close. And this happens to be the power button that we're waiting for that to basically to close. So before we wire everything up, we have everything ready to go here. Basically, we have to push that switch for things to start to move. And usually just when I ask Mark if he can basically give us a hand. So there's Mark's virtual hand, and he's going to push that button for us. I have so little in my life here, so please.
I'm a hand model today.
There you go, yeah. So hope that amused you. It amused me. I still laugh at it. Anyway. So now we've got that power basically button closed. You can see in purple where all that stuff ties off to. So there's our neutrals. Basically, there's relays in here that are going to close based on combustion. So these are going to close to power things like the gas valve and the motor, fan motor, etc. Any pump outputs, so there's the domestic pump and the boiler pump, 20 pump outputs, they're up there as well. So we switch those off of 120 volt up at the top. But those relays are basically, all of the neutrals are basically part of that incoming neutral that you tied off at the 40 plug down at the bottom of the control. All right, so that's where it sits. And you'll notice it actually comes right back up here, and it sits at a 96 plug. So the 96 plug, we're going to talk about this in a second, it kind of moves the power through. And then that comes back through the 96, and it's going to come back through your, down to your control console, or down to your pump module, and it's going to terminate at X1-7. Right? So that's going to be the number 7 connection right here, X1-7. That's where that neutral has come back from the control console and basically ties off all of your neutrals for all of the coils in those relays that we just reviewed from K1 to K6. All right, so there's where our neutral comes from for the coil. It actually started down here, went all the ways up through the control console, through the 40 plug, paralleled off to all of your contacts at the combustion controller, back up through the 96 plug, and came back down through, terminated down here at X7, which ties off all your neutrals. So there's your neutral connection. We'll do the same thing with the power.
Scott?
Yes, go right ahead, by all means.
When he's talking about the nomenclature, you see there's a lot of X numbers. The X number, so X3 or X7, indicates the terminal block. The number after that, so X31 would be pin 1 on that terminal block. X32 would be pin 2 on that terminal block. The reason why I point that out is not all of the connectors are big enough to actually have the numbers printed on them. You get a plug with 15 or 20 connectors on it, and it's not going to be able to write the number on every one. So when you look at the control board where it plugs into, there's always a triangle or a diamond or some of the stars beside pin 1. So if you're looking for, you know, the X3 pin 6, you would go to the X3 connector, and pin 1 would have an indication that that's pin 1, and then just count your way across. So that's how you read the wiring diagrams on all of our controls, whether they're residential or commercial controls. So the X number is the terminal block, and the number after the decimal or the dash is the pin on that terminal block. So you can sometimes just count across to find the one you're looking for.
Excellent. That's like a lot of the sensor connections and stuff like that with those multiple tie-offs. That's a good point to mention. These are all, I think, pretty much all numbered, but a good point to reference there. So so we got the power coming in. Thanks, Mark. And he's already pushed the start button here, so we don't have to get him to do that again. So there's our 40 plug, comes down to our switch, which is already closed. And then we go through another fuse. So the control console is fuse protected like the pump module. And then actually for, just so you know, there's actually a spare fuse located in that fuse holder. So there's one that's basically plugged into the control console, and there's a spare one if you unplug that you can access. So say you had a pump that basically popped a fuse or whatever down at the, the F1 fuse or whatever down at the pump module was open because of a bad pump. You diagnose that. You actually have a spare fuse up here, so long as somebody else hasn't already used it, but it would be available there too to basically allow you to pop one more fuse before you got to go buy a pack of fuses. But that's basically sitting right there. So once the power's on, we go through that fuse, and now, again, that line voltage is now basically idling, sitting there waiting for these relays here to close, and they're going to close as a function typically of boiler operation. So the pumps will operate based on load and demand, your domestic pump and your boiler pumps, for instance here. Gas valves and fans are all going to be part of the ignition process, so those relays are part of that function. The line voltage now goes right back up again to that same 96 plug that the neutral was tied off on, and it moves in a different direction here. We're going to come back to that in a bit, but for now we're just going to bypass these little branches here. We're going to get to that, and we're just going to kind of move back down to the pump module. And we're back at the pump module now, and we see that this is terminating now on the X1-6. So X1-6, right there beside the 7. And when we push the button, we've done nothing else but basically turn the boiler on and power it. And the power directly goes to K1 and K2 and closes on powering up of the boiler control. Right, so there's nothing else that we've done here. We haven't created a demand or anything. We've just turned the power on, and we're going to energize these two outer relays, K1 and K2, on power up. And now, of course, you see the power is now past the K1 relay here, the switching contact closed, and basically power is now sitting here at our multi on the 2820 output. At the 20, at the 21, and at the 156B. So as soon as you power up the control, you're going to have power on 156B. 120 volts sitting right there, which is fuse protected by the 6.3 amp fuse. So if I put anything on this as far as a load, I have to remember that we're also picking up some other contacts here. So we got amp draws from different pumps here possibly, and I can't exceed that rated fuse that we have in here, or we're going to start replacing a lot of fuses over time. So just be aware of that. The other K2 relay coil closed here, the contact here switches, and now we are powering up the 156A, which in turn actually powers up the EA1 module that sits over here on your control. You kind of got to close your eyes and picture the EA1 module over there, but this is where the 120 volt comes from to power that. And we power up the 96 plug contact here, which usually has a jumper on it between 1 and L, and that's programmable for like external disables and stuff like that. I rarely recommend using it because there are easier ways to do external disables and stuff with the boiler, just using a dry contact versus line voltage. So we usually just don't, it's in the manual, but we don't talk about external disable in this one very much, at least I don't. But that's where the power comes from. Now, if we kind of move back up to the control console again and kind of look at where that power is moving. Again, the end result here is trying to figure out why we're getting a 29 on address 38. We're going to get there. but we got to find out where all this power is moving through. So that's the first thing. All we did right there is power the control up. And we got K1 and K2 energized, and we got power down to different areas of our pump module. On this side here, now we're going to move basically through the neutral. So now with that 96 plug, where it's split off to go down to the pump module, we're going to go this way now, back to where it's coming over to another circuit board. And the power now from red, we're going to go to green. So there's our 120, our power line voltage, coming back over to another board over here. And the board that we're dealing with is on the right-hand side. It looks like this. You'll see it on your, if you tilt that control console down. And the wires that we're looking at are actually sitting right in here. And they're off this little 96 plug. So that blue that you see right here is actually the neutral that we're describing or tracing on our diagram here. And the 120 volt is this little connection right here on that board. It goes back to the 96 plug and terminates right here. So that's plugged right into that board right there. So there's our neutral. There's our line voltage off of that unit. And there, of course, there's the ground. Once that power goes through, we are going to basically power up or energize or have 120 volts at these relays. So there's the K12 and the K11 relays. So these are switching relays on this board, and they are switched off of a 24 volt DC signal. So something a little bit different here. We've been talking about 120 volt. These are actually switched off of a completely different type of power connection, 24 volt DC. But we are supplying 120 volt to the relay switching contact. So whatever we actually switch, we're still going to measure 120 volt as a result of that coil being energized from between the K11 and the K12. So let's have a look at what these little devices do. This board is actually connected to our control console. And the control console is going to switch 24 volt, either K11 or K12, depending on what that particular function is going to do. So let's have a keep going here. So as that power moves through, you can see it as it comes up through. It hits a 2 amp fuse. That's a little brown button fuse, which is basically soldered onto the board. It's a non-replaceable fuse. And 2 amps. And once it goes through the fuse, it hits the 53L. So this little yellow plug here off on the right-hand side, the power hits that. And once it goes through that 53L plug, it's going to come back down to the pump module. We're going to have a look at that in a minute. But what would actually create the power hitting that 53L? So what causes that those 24 volt DC relays to actually get energized and close? What types of things are going to cause that from the control console? Your call for heats. So if you have heating circuits, and this is a discussion maybe for another day, talking about heating circuits and zone controls. I think Mark has done a recent presentation that's archived on our website there, talking about zone controls and heating circuits and stuff like that. A lot of good information available if you're curious. But that will cause basically a demand, basically to switch that contact and have that 120 volt go to the 53L. If you did zone controls I just talked about as well, so you hit a dry contact on one of the DE contacts on the EA1 module, which would create a call for heat, that would also switch a 24 volt DC signal to cause that relay to close. Domestic hot water demands. Any external demands that we're dealing with, or 0 to 10 volt inputs from a variable, set point type of controller that uses 0 to 10 volt inputs to control set point temperatures on your boilers. All of those demands that we want the burner to fire will cause a 24 volt DC signal to switch those relays to cause that burner to fire. So as we go down from that 53L, we are down in this particular area of the control. So we're coming back down here again, and you'll see that coming from the 53L, terminating right here on our X1-2. And that's sitting right here on our control. So we'd actually check for 120 volt there as a result of that and verify we got 120 volts there. If we have 120 volts at the X12, we should have this particular coil, which is your K6 coil, energize and close the contact now that we're dealing with down here. So now we've closed this K6 relay. We go through another little 4 amp fuse inside the pump module. You don't see this fuse. It's covered by the cover for the pump module itself. But there's a little, again, another little soldered in fuse there, which is a 4 amp fuse. It moves through there, and then that 120 volts sits on the L of our multi-plug. And that multi-plug was mentioned in that 29 information when we read it earlier. So there's the multi-plug. Usually there's an installed jumper there. Which means that when the jumper's in there, basically that 120 volt goes directly from L right over to 1, and now we go right back up, and we're going up to the X1-1 terminal on our control, and then from there it goes back up. We're going to use a blue here to kind of cover that, and we're going to go right down again here, and we're going to terminate on the 53-1. On the basically on the 53 plug, so the 1 terminal. That is your basically the call for heat. So that's going to cause the action where the burner is going to trial for ignition. So once we get power right here, that's when the boiler should start to fire, and we should have operation as far as burner firing to set point and all the good things that go with proper operation. If we don't and get 120 volt there, then basically that's where the 29 might pop up. So we have a call for heat, but we don't have the proper voltage terminating in this particular area. So the boiler goes into this wait state where address 38 goes into a basically a value of 29. So different things that we want to check for here. This multi-plug sometimes is used for external safety. So in the manual, we detail certain areas, things like utilizing gas pressure switches. We have a detail here of using field supplied auxiliary low gas pressure switches or high gas pressure switches. You could utilize external fixed high limits, that sort of thing. And what we'll do is we actually take the device, and it needs to fail open. So if we have a low gas pressure in this case, it opens that contact, and basically there is no power going to 1 now. So when there's good pressure, the contact is closed on the low gas pressure switch, and it acts like the jumper would on the multi-plug. So from L over to 1, no problem. But if there's any issue as far as safety, that contact opens, and now we separate the 1 and L here, and no power gets over here. So nothing's going to get up to that X1 terminal, and nothing's going to terminate on 53-1. So we're going to have that address 38 be a value of 29. So check any external safeties. If there is something wired to the multi-plug, we have detail of that. It can also be a low water cutoff in certain applications, depending on authorities having jurisdiction. They may want to have a low water cutoff as well as a flow switch in your system. And we do the same thing here. The schematic shows you that that contact needs to open on a failure, on a low water condition, and effectively that's going to block the burner from firing. So that's the end result. Is the desire is if there is something that's not safe externally that's being picked up by a safety, we want to block the burner, and that's going to achieve that particular effect or impact here. So until we rectify that and allow that power to short over to number 1, it's going to stay in basically a standby type of condition. So have a check of your external safeties. And technically speaking, probably one of those is the reason why you're having the issue. So we need to basically troubleshoot that. The other thing is to check your L to ground. So basically, if there's no safety, or the safety was basically fine, or you had a jumper in the multi-plug, so there's no external safety is actually wired, we can actually have a measurement here. Do we actually have 120 volt here? So we start working backwards with our voltmeter to figure out where that power is being interrupted. So if I don't have power here, I can start working backwards to find out where that power is basically disappeared. At the 1 here, doing the same thing, 1 to ground, checking to see if we got power there. If you've got, again, this is part of our, our carrots that we give you guys when you come to our academy sessions. We've got the little service screwdriver here, which is an excellent little flathead screwdriver for these little terminals that you're dealing with on a lot of control devices these days. But it also has a little LED there that will actually light up to tell you that there's power. If I kind of switch this back and forth a bit, you might see that LED kind of flash up there. It's a 120 volt or 240 volt, and that little LED is sitting right in there. So another device you could use to basically test that power as you move along. We're going to go up to the control console here, and we're just kind of working. Where is that 120 volt basically showing up where it isn't in the next step? So do the 53 plug. So basically we're checking power here right now between the connection of our 120 volt to the board here. We could do that actually at the 96 plug if we wanted to ground, or I've done it here from ground to the actual plug terminating on the console or on this little board, and check for 120 volt there. So if we have it there, then we're great. If we don't, then there's an issue with power at the control here. We'd have to figure out what the wiring's going on there. We check for power now at the 53L, right, to ground. We got power at that spot, right? That basically tells us that we've got power from these little switching contacts or not. And then of course the 53 to 1 connection here, we can check as well. So basically what we're dealing with here is just defining where that power is being interrupted. And from that point, we can diagnose where that problem is occurring. So if we have an issue up here where we're not getting power through these little relays, then this board here can be the problem. So even though we've got connection here, if we don't get that power coming out of the 53L and then coming back on the 1, then our power is interrupted here. So we had power here, but no power here. A pretty good indication that this module here is our problem. And that module is actually replaceable. It's a component. You don't have to replace the whole control console. It's just that one component of it. And there's the part number, 7509610. And if that's causing your issue, then that's what you're going to see. We have to call for heat, but the power's not getting back to basically give us the burner control, the okay to fire. It's going to sit there in a wait state, waiting for that power to reach that area. And that's, as a result, is going to be 29. Another test is obviously if we had a problem down here. So if there's an issue where we had power at this spot, no power at the 1 coming back to our control, then our power is interrupted somewhere in here. So we could check, basically measure power at the 2. We got power here, but nothing on 1. We can start looking at, again, as I mentioned before, looking at the multi-plug L, look at the multi-plug 1. You could have a bad relay. I haven't seen that yet, but I have seen this fuse here pop from time to time. If people have inadvertently put some load on that and powered it up and popped that fuse, it's not replaceable. You would have to replace the whole pump module at that particular point in time. But again, just about isolating and eliminating where that power is being interrupted, and you'll find the spot, and it's usually going to be one of these two things. The part number for the pump module, 7839389, for all the different controls that we're looking at here today. And finally, just to kind of finish up with the fault address 38 with a 33. If I go in here, basically, and this is relative to all of the boilers that we're talking about, WB2B as well as the B2 series of boilers. If you see a 33 there at the value of address 38, two things: check power or replace the control. So basically, the problem is the control doesn't have the proper supply voltage, or there's some sort of internal fuse issue. So one of those internal fuses that aren't replaceable is the issue. So the test here is go up to your 40 plug, and this is different for the B series versus W2B series. If I check the 40 plug on a B2 series, I'm going to check for 120 volt to ground on my 40, and I want to see within about 10% of the rated power. If it's 120 volts, I want to make sure that that's up above about 110 volts, or we could have an issue with this address 38 being 33. If it's a WB2B control or boiler, and the control there is actually wired or off of a pump module that comes with the boiler, and the WB2B boilers worked off at 230 volts instead of 120. So we would be looking for the same thing. Within about 10% of that 230 volts, is what we're looking for. And if it's below that, then we would have to basically we'd have a power issue. We'd have to get some sort of a power filter or conditioner there to basically make sure that we don't have any issues with the control long term. But if 33 is basically, if the power is within range here, the only recourse you have with a value of 38, 33 here would be to replace the control console. So if you've checked the power, the only step you have is to replace the control console itself. And the reason that could be is because that area has, intermittent long-term issues with voltages, so voltage spikes and brownout conditions in that particular area. That wears on the controls over time, and eventually you end up with that address 38 being a 33. Lightning strikes, power surges, those types of things can cause that particular problem as well. If you get water on the controls, there obviously can get the smoke out of the control, and you just can't get that smoke back in again. Old joke. And the problem there basically is the only thing you can do is replace the particular control. So again, a lot of times if you know that you have situations where, and we have some areas here in the West Coast that you put a voltmeter on there or a voltage recorder on, it looks like some sort of a cardiogram where you have these huge peaks and valleys as far as voltage fluctuations. That is going to wreak havoc on your electronic devices. And again, we always recommend having a look at different power filtrations that will look at both brownout, low voltage as well as high voltage, and keep your controls operating within a really good parameter. Goes a long way to making sure those controls are going to be robust on a long-term situation. So there's a little bit of information for you guys. I hope that you find that stuff valuable, and like moving forward, knowing where that address 38 is and what those values are can really shorten those times that you're standing in front of there scratching your head, kind of wondering what's the next move, what's the next step here to getting this issue resolved, and moving on to the next one. So hopefully you found it valuable. And that, I think, is we've done the three presentations here, one after another. We're taking a little break. Mark and I are taking a little hiatus here. Well, I think we're going to be back in September, Mark.
Yeah, that's the plan. They're going to publish a webinar schedule for September, October, as soon as we figure out what we're going to do in what order. And then there'll be some further ones from both the U.S. Academy and the Canadian Academy to North America as a general. And they'll be publishing those in the next couple of weeks, hopefully. So we'll have some things for September, October. Questions today, they were asking them in the chat box. So I'm going to see if Miranda can collect those and put them into the questions. Hopefully we can still get those out.
Okay.
There were a question on a 2-amp fuse, and there are two 2-amp fuses in the boiler. One is in the EA1 module, and the other one that Scott pointed out later on in the presentation is that non-replaceable fuse on that little board next to the main controller. So just so there wasn't any confusion with my answer there, that there are the replaceable 2-amp fuses in the EA1 module, which is the left box in the main control, main power connection box. And there is another one on that board that's a fused, soldered in fused relay. Yeah, and it's actually protecting the 24-volt DC circuit, not the 120 circuit.
That's good to know. Yeah, so there's basically just some information for you about what's coming up. So you just basically stay tuned. Check our websites where you get your information from. Check your Viessmann Orange app when we're ready to present the next one. We got some pretty good topics Mark and I have discussed. So we're looking forward to getting back at it with you guys here. And if you haven't signed up for tomorrow's presentation that Jay is doing, it's a really good complement to what we just talked about here today. So he's going to continue on with the Vitodens 200, talking about control navigation. So getting that little HO1B control on the face of the boiler, and then talking about some service and maintenance things. So hopefully you guys will have time to get that in. But I want to thank you guys for hanging with us, staying with us. And like I say, if you've got any other questions you kind of come up with later on at aha moments or whatever, and kind of curious about something, you can always get in touch with us after the fact, and we'd be happy to take your information. But if there's nothing else, then thanks, guys. And like I say, we've taken up enough of your time. Have a great day.
Thanks, guys. Have a good day.
Thank you.